So where we left off last time was going through the structure and the functionality of the LockManager app server. And I talked about how the controller was implemented, and we talked a bit about deferred result and the way that that helped to abstract things so that you didn't have to have the server chew up an HTTP worker thread. We also talked about the LockManager service. I gave an overview of some of its key methods, and we described the algorithm for implementing a distributed semaphore using an array blocking queue. What we're going to do now is we're going to actually walk through the code, and I'll go into some more details about how everything is designed and implemented. So you'll notice here we're going to talk about both the controller and the LockManager service. We'll spend more time on the LockManager service because it's got a lot more interesting stuff, although the controller does, in fact, have some interesting stuff in it as well. So you can grab this code here in my GitHub repository in the EX5 project in the web MVC folder in my live lessons repository. So here we are in the EX5 project, and we're going to start by taking a look at the components that are in the server project. And here's the code for the LockManager application. Remember, this is the main entry point into the service and the microservice that we're implementing, not the service, not the Spring service, but the microservice. And this is very simple. We make it a Spring Boot application, which will make sure that Spring will do the various type of scanning. We tell it where to look to do the scanning, which is in this package up here. And we also enable async. Notice the use of these these annotations, which will enable support for things like asynchronous method execution in a Spring server-side application. And we'll talk more about how that all gets wired up here in a second. But this is really nothing that much different from what we've seen before. We have a main method that will run the LockManager application class. But the key thing here that's different is we enabled async. So let's go over, take a look now at the controller. Some stuff here is pretty much par for the course. We auto-wire the service like we always do. And we also go ahead and have a create method, which is going to take an integer with a permit count, and it's going to forward to the service to create a LockManager with a certain number of permits. You can see it returns that LockManager here as a return value. LockManager is defined over in the common folder, and you can see what a LockManager is it's just an object that has a string, which is the unique name of the LockManager, so we can differentiate different LockManagers, which have different groups of locks they're managing. And then we also have a count of the number of permits. There's something else here that we added, which was basically the ability to check to see if two LockManagers are equal. And a LockManager is considered equal if they have the same unique name. And we use that in a couple places for comparison purposes. We'll see that when we look at the code. And whenever you override equals, you should also override hash code, which just hashes the name and returns a hash value for that. So that's basically what the LockManager does. And what's cool about this is a user-defined type that we make. It's not part of Java's standard class library. And we can pass that back, and Spring knows how to encode this object in such a way we can pass it from server, which is the factory method here, back to the client, and then the client can invoke operations on it. Let's go take a look down here at acquire. This is the more interesting method. And as you can see, this method, everything here, by the way, uses post. Post mapping is used for everything, and that's because we're changing the state of the server with all these operations. So in this case, we're making ourselves a LockManager, and that updates some server state. Down here in acquire, we're changing the server state to make a modification to the internal LockManager that's being referenced here, and so on. So acquire takes a LockManager. It's going to return a single lock, and the way it's going to do it is by using this deferred result mechanism we talked about before. So what's interesting about this is this says deferred result here, lock, but what really goes back to the client is just the lock. The deferred result is just used on the server side in order to be able to allow the computation to run in the background, and we'll see how that works in a second. So we come in here, we make ourselves a new deferred result. Then we make ourselves a new callback. Here is what callback is. Callback is a little thing that we define over in callback, which is in the common folder. And you can see it's just a very simple callback interface that has two hook methods, on success and on error. And if we succeed and we get a lock, then we give the lock back with the on success call. If we fail, we give the throwable back down here. Why do we need this? We need this because we're going to asynchronously run the acquire operation in a background thread. It'll end up using a virtual thread, as we'll see in a second. And that particular background thread will go look up the lock manager and acquire one permit from it, one lock from it. And when it's done, it's going to invoke the callback to either say, I succeeded, in which case it updates the deferred result, so it'll send back the lock to the client, or if things go awry, it'll tell the deferred result what the error is. So it'll set the error result. And we need to be able to do it through a callback because the method is going to return right here. So deferred result is returned. This does not go back to the client. This is simply stored in the server in Spring, in parts of Spring, such that when the deferred result is set to either lock or an error, that's a trigger to the server-side code that's lurking under the hood to send back the result to the client. Now, again, why are we doing this? We're doing this because we don't want to chew up an HTTP handler, sorry, an HTTP worker thread, or what's sometimes called a servlet thread. We don't want to chew up the servlet thread by having it wait while we do this potentially long-running blocking operation, which is this acquire call here. So that's going to run in the background. But that's the basic logic. Just to be different, just to show a couple different ways of doing things, the version of acquire that takes a permits count, which is going to get a number of permits, is not going to use the async method that we're going to use here. We're going to use a different approach. And what we're going to do is we're actually going to build that logic into the acquire method here. So you'll see when we look at the implementation in the service that that's slightly different for the version that acquires multiple permits than the version that acquires a single permit. However, what is also interesting here, notice this returns a deferred result, which is a lock. The second acquire method returns a deferred result, which is a list of locks, because of course we're going to give back a bunch of locks, the number of locks corresponding to the permits parameter. And so this allows us to be able to do that. And we'll take a look at that code here shortly. The release methods are far easier, although there is one interesting thing we're going to show here in a second. The release method here takes a lock manager and a lock as request params, which means that's going to take a look at what's encoded in the URL itself that's passed over as part of the URI. And that's going to just forward to the service and say, hey, please release this lock back into the array blocking queue. And then we have a second version here, which is going to take a list of locks, which obviously would have been obtained from this method here, the one that returns a list of locks. And this is going to release the list of locks back into the lock manager and its array blocking queue. Now, the thing that I want to point out here that's a little different is, in this case, just for fun, we used request body here. So rather than encoding the list of locks in the URL that's sent as a post URL, instead we're going to encode the list of locks in the body of that post request. So that's one of the other differences between get and post. When you call get, it's really intended as a read-only operation. It just gives you back whatever you ask for. With post, you can update stuff. And you can also put things in the body of the request. So we put the list of locks in the body of the request. We could have encoded it into the request param, but I'm trying to show you the more conventional way of using post. So we put it as a request body. There can only be one request body annotation on a post request. You can't have multiple request bodies. However, you can have multiple request params, as you can see here. Okay, so let's see if just a few more things here on the controller side. Other things just to point out, here's the constants file that just has the symbolic names for the various path routes we're going to stick into the URLs on both the client side and on the server side to extract things and dispatch the right method. Here is lock. So I didn't talk about that yet. So lock is an abstraction that is going to be passed around, or it's going to be returned by acquire, either one at a time or a list of things. And it defines the name of the lock. It is just a number, very simple name. And then we also have some other constructors that can set that name and something that returns a string. So this is what we're going to use in our array blocking queue to keep track of the permits that are available. And each one has a separate name. And the last piece of the puzzle I want to talk about at the beginning here, before we get into the LockManager service, which is the big kahuna, is server beans. So server beans is where we're going to put the beans that we need in order for this to work properly, this application to work properly. We've got two server beans here. The first one is going to be used to create an async task executor. And you'll see where this gets used. This gets used in the LockManager service, which we're going to talk about here shortly. And what it does is it makes, when it's called, and you'll see when it gets auto-wired together when we look at the LockManager service, when it gets called, it's going to go ahead and create a new async task executor, which is going to be the new virtual thread per task executor. So every time we need to make a new task to run a longer running operation, we're going to do it using a virtual thread. So we're going to have a pool of worker threads, just the canonical HTTP worker thread pool or servlet pool threads for handling incoming requests, but then things that are acquire-based that could take a while to run are going to run in a separate virtual thread. So that's one of the things we're going to use for this. The second thing we're going to show here, and we'll talk about this again very shortly, is this bean, which is going to return a concurrent hash map. And you'll see how we use this in order to be able to associate a given lock manager with the array blocking queue that corresponds to the permits that it's managing. And we use a concurrent hash map for reasons we'll talk about here shortly, having to do with wanting to be able to allow multiple threads to simultaneously update or read the contents of the map without having to worry about race conditions. So those are the server bean stuff. The other thing I'll just point out here real quick, there's just a utils class that logs things and generates a unique ID, and we'll see where that gets used as well. Okay, so that's kind of the background of everything except for the LockManager service. So now let's go ahead and take a look at LockManager service.